Hey, grade nines. I hope you had a fantastic spring break, and I hope it was restful because it was kind of a weird one to go into. But I hope you're doing well and rested and ready to get back into it. If you don't remember, we were working on linear relations just before the break, and it's one of my favorite topics because there's so much that you can do with it. Basically what we can do is we're able to take some information and find a linear pattern, and we can make graphs out of that, which is pretty sweet, right? Maybe not so much yet, but if we can find something like a pattern, we can predict some data, we can figure out what's going on with our information. That's kind of what we started with before the break. So we're going to look into that a little bit more. I'm going to move on to my whiteboard to show you. You'll see that my setup isn't the same as usual, so bear with me on that, and we'll take it from there.
Yeah, so we're going to work through some examples here. In fact, just one example, so I'm just going to draw it out on the board for you. We're looking at rectangles and their perimeter. Just take note that each of these rectangles is made up by adding a bunch of squares together. So rectangle 1, for example, has 2 squares put together. And we're going to say that the side length of each square is equal to 1. So if we add up every single square side length, we can measure the perimeter just by counting. Now, we can also represent this data in a table, which is a lot easier than just in words. So rectangle 1, for example, has 6 units for perimeter. 2 is 8, 3 is 10, and we could probably guess 4 as well, because there's a pattern here. And yeah, it ends up being 12. So it's a good idea to just have that as a note. I'll also give you an equation that represents what that relationship is. Now, the main thing of linear relations is that we should be able to represent our data as a graph, and that's probably the most useful part. So we put every single piece of information that was in the first column of our table on the bottom of our graph, that's where R is, and all the other points go on the vertical axis, that's where P is on the left side. And we use our table of values, it's kind of like Battleship, to plot each of these points. So at 1 I should have a 6, 2 on the x-axis I should have an 8, 3, 10, 4, 12. And essentially what's happening is every single point is moving over to the right by 1 unit, but then it's also moving up 2 units. And the last thing is we don't have to connect the points. In fact, if we don't know what the points are in between, say, 1 and 2, because we didn't have 1.5 rectangles, we don't have to connect our dots because we don't know what that information is. What you could do, though, just like what I've done here, is I've used a dotted line. That's totally fair game. Okay, so the last thing that I need to give you here is a definition. So linear relationship, or linear relation, and that's when the graph of a relation is a straight line, then we could say we have a linear relation.